Hello, I'm Filipe Mesquita, VP of Research with Diffbot, and today I'm going to talk about the lessons learned applying NLP to create a web-scale knowledge graph of the public web. Um, this conversation today is what we've learned in the last 4 or 5 years building the Diffbot Knowledge Graph. It is a general purpose knowledge graph, but we do have some applications for healthcare that we'll highlight today as well. Well, first of all, what is a knowledge graph? If this is the first time you heard this term, it has been called before a knowledge base, which uses a graph structure data model. But you can think of a different type of database, a database that's better for representing knowledge. And the main components of the database is that you have nodes. So these nodes can represent entities like people, organizations, uh, a drug, or effect of a drug. So anything really you can represent as a node. And then the relationships between these nodes, you can see their arrows, we call them edges. And that's the basic components of a knowledge graph. And I'm going to talk about some use cases that our customers have used it for healthcare, but you probably have seen knowledge graphs being used most commonly at Google. Like if you search for Diffbot at Google, for example, you see there's this little panel on the side. This is data, like so there's a summary about Diffbot, when it was founded, the headquarters. This is data that Google have created and put in their knowledge graph. And they use both humans and machine learning to build this that we know of. Diffbot is trying to do it in a different way. This is the Diffbot profile in our knowledge graph, and we're doing this 100% automatically, as I'm going to go into today. Let me go back to the presentation. Um, the main problem that we're going to talk about today is that knowledge graphs are often limited by human curation. Like I was using Google Knowledge Graph as an example. Um, we know that there's a lot of the data that it's in the Google Knowledge Graph is based on a human went there and entered the data. This could be a knowledge panel on the web. This could be a project like Wikidata, where Google feeds. Google Knowledge Graph was actually built upon this crowdsourced knowledge graph called Freebase. And there are some problems with doing this with humans, right? You have limited coverage on what you can represent, right? There's only so much human resources you have to add entities and add relationships. Another problem is you have limited freshness. Right? You're not always looking to see if the fact or this relationship that you've added, if that has changed. Maybe it's outdated. Maybe it's not current anymore. Sometimes there are new entities that appear that you're not able to react quickly and add them to the knowledge graph because again, depends on a human going there and adding that information. And it's also limited provenance. Right? Not always you know where that knowledge came from. Um, what's the origin of a fact? Diffbot is trying to solve the problem of creating these knowledge graphs automatically, and we are using the World Wide Web, right, the internet, with all its noisy and structured web pages that contain the information that we as humans have already put all the effort into writing on the web. It's not in a format that machines can quickly and easily use the information, the knowledge, and so that's where Diffbot comes in. We're trying to get the information and create this really comprehensive knowledge graph of the public web that's 100% automated. There's no human involved. It's high quality. We are trying to denoise the data on the web, and it's again at web scale. So just some facts about the Diffbot Knowledge Graph. We launched in 2018, and we already have 10 billion entities and 1 trillion facts, ballpark. We're building this knowledge graph again from crawling and extracting information from the web. Our indices right now are around 80 billion pages. And the main entity types in terms of number of entities are people, organizations, places, products, events, articles, discussion, etc. We created this knowledge graph every 3 days. So the idea is that we try to build the new knowledge graph from the webs, the sources that we have cached already. And this allows us to improve any component and improve the knowledge graph thoroughly every 3 days. And for that, we have 2 data centers locations here in the Bay Area, and there are many different ways that our customers can access that knowledge graph. Mainly business looking for APIs, but we also have dashboards and other integrations with Salesforce, with Tableau, etc. Today, I'm going to talk about 3 things: how healthcare companies use the Diffbot Knowledge Graph, how we apply NLP to create this web-scale knowledge graph, and the lessons learned along the way. Some healthcare use cases. So the use case number 1 is the mining of medical news. So there's a lot of information on the web about medical concepts. And I'm specifically talking about news and things that people discuss on the web, less about academic articles. But it's interesting for healthcare companies to understand what's being discussed, and if there's new evidence or new ways of treatments that people are discussing on the web, they want to know about it. Right? So we are able to crawl the web, find articles, get a clean view of the article. So we remove all the ads, all the navigation bars, and you have a way here in the knowledge graph to search for it. So I'm searching for articles that talk about oncology or cancer in the title, and I want those that have been published in the last month or so, and I can sort them by date as well. So I can create on an article here to see this article, and you see this article has already been extracted. We have the title is separated. All this information you can see on the JSON as well through APIs, but this is just a demonstration. There are quotes in the articles that we have recognized who are speaking those quotes, the concepts that are being mentioned, or the entities that mention tags in the article, as well as the clean text, images, etc. This information can also be used to go deeper. You can put that text into a natural language extraction and understand the relationships between these entities in the text. Right? So we have TGen, which is Translational Genomics Research Institute. It's talking about Daniel von Hoff, which seems to be a professor in the institute, and all the information about these entities and how they are connected from this text. So that's the first use case, is to mine medical news, medical discussions on the web. The second use case is for market intelligence. There are actually 14 million companies involved in healthcare in our knowledge graph, and you can search all of them, or you can go deeper into a niche. For example, you can look at what are the Series A startups working on telemedicine. And there's not many of them, but you can actually find them on the knowledge graph. You can find who the companies, who are the CEO of those companies who work there. If you want to contact them, maybe they are upcoming industry player on your niche, we can provide that data as well. And the third use case is to provide sales intelligence for companies in healthcare. Of course, this is a tool that works for any customer. It actually takes as input the customers, your customers that you have won recently, and is able to find more companies that look like your customers. Another thing you can do, and this example here is for Diffbot, so the organizations are not actually in healthcare, because not all of them anyways, but the idea is that you can do this for any company. We can put in your customer information, and you can get a recommended company list like this. Not only can we find companies that look like yours on the web, we can also cross-check the information with companies that are visiting your website. So in this example here, you can see that the top company have visited our website 16 times in the last year or so. They are looking at pages about websites and image publishing, and they are similar to other organizations that they're already our customer. All right, so those are the use cases in general for healthcare. Right now, I want to give an overview of how we build this knowledge graph with NLP. Well, we start with a crawl. We are finding these pages on the web, and we figure out that if you know the type of page that's presenting data, we can more easily extract that data from the page. So the first thing we do is we try to figure out, is this page a product page or event page or an article page? So there are a fixed number of types of pages, and also the language. And once we know that, then we can apply specific extraction and NLP extractor to it. So in the case of a product page, we can look at the natural language of the page as well as some visual cues of the page, because we rendered these pages on a headless browser. And you can figure out, what parts of these pages are image data, what parts of these pages are structured data. They already have a title that's separated in the page, what price, etc. And you can also figure out parts that are plain text, right? Natural language text. In this case, a description here. Natural language text go into that tool that I showed before, where the input is plain text and the output is a mini knowledge graph. That is a structured record that we can use to build the knowledge graph from the entire web later. So I'll click here quickly to show that. So this is, again, the demo of the knowledge graph. I'm going to go a little bit deeper this time. This is the input. It's a plain text, a description of a person. This could be basically anything. It could be a news article, it could be a description of an organization, product. And we are finding what we call the entities, right? So Mike Tongue will be an entity, a person. And not only are we finding Mike Tongue's name, we're also finding all the other words that refer to Mike Tongue. So for example, he. Let me get a little bit closer to make sure that you can see this. Like if I hover over he, you can see that he is mentioning or is referring to Mike Tongue. Like this pronoun he as well. And there's a partial name match as well here for them. So this is called graph resolution, a very hard problem, but we've been working on this for a while now. I think we're doing a very good job at this. Once we can do these steps, you also have the problem of actually there are over 30 Mike Tongues in our knowledge graph. So we want to figure out which one is the text talking about. And you can see that we actually have a link to Mike Tongue to our knowledge graph, and you can see it here, his entry. You can see a summary about him, his experience, photos from the web. This is 100% automated information. You can actually look at the JSON of Mike Tongue. You can go to his origins, and you can see all the pages on the web where we found this information. You can see there's a page in Crunchbase that talks about him, in Stanford, in LinkedIn, ZoomInfo, ResearchGate, SlideShare, Twitter, etc. So this is basically all the places where we found information about Mike Tongue automatically. And so this allows us to put a node in this graph, right? You can see Mike Tongue here, and allows us to have an image from Mike Tongue, something that, of course, doesn't come from the plain text. It came from the knowledge graph. In addition, we are able to find relationships, right? So these are the entities that I was talking about, like is the list of entities, but then these relationships or facts about mic tongue. And I'll hover over each fact, and you see that the sentence where we got this fact from the text is highlighted. Right? So the fact that he's a founder, the fact that he's a CEO, that he's a member or employee of Diffbot, and currently, right? So this is actually something we call qualifier of a fact. So we're also telling you information about the relationship itself. Um, and other information here. He was an advisor for StarX, went to Stanford, worked at eBay, Yahoo, etc., Microsoft. And this is often called relationship extraction and relation extraction. Very well. So this is the demo of the natural language API, how we can get structured data from plain text. Once we have this structure record from each page that we extract, we still have a big problem, which is to integrate all of the data into one cohesive record for Micton. I'm not going to go too deep into that problem today because we're focusing more on NLP, but there are actually some interesting problems there on figuring out what the similarity between the facts about Micton in all of these pages. There's some NLP problems there, and there are some normalization problems as well. Right? The fact that there's so many ways of saying that he's the CEO of Diffbot, right? So many ways to say that he's a founder, right? So in one page, he's saying he's the founding CEO. The other page has a founder. The other page is just CEO. And we need to combine all the information. Some information is actually wrong, misleading, or outdated. There's another part of the knowledge graph that needs to deal with those problems. I'm not going to get into details today. But the idea is that we can create a better version of the web data for Micton than the actual web has. We can clean it, can duplicate, and then have the information clean on our knowledge graph, where you can quickly search. And it's not trying to pull the information on the fly. It's already indexed. The record exists. We can run queries on it. Very well. I want to talk about some lessons learned of creating the knowledge graph and applying NLP to create the knowledge graph. The first lesson learned is that error propagation cannot be ignored. So error propagation happens when you have a pipeline system where you have one input and you have several components, usually NLP components. One feeds, the output of one component is the input of the next. So we have this chain in a pipeline, and at the end you have your final output that goes into your database. You go to the knowledge graph. This is something that if you've seen the natural language API that I was demoing before, you see there's several steps there. You're finding a name, finding coreference, find the relationships. So many systems are solved that way, right? You modularize it. You have one component for finding the names, one component for coreference, one component for finding relationships. And in the end, they all chain together. You evaluate them separately, but they're chained together. And the accuracy is actually okay. It's pretty good for each system individually. But then when you put them together, what you see is that all these small errors compound, and the error is propagated throughout the pipeline, and in the end, you have this big error. What we found is that ideally, if you can, you want to avoid that chaining of components that becomes a pipeline, and we've figured out that doing multitask learning, which means that we have one model that solves several tasks jointly at the same time, we can achieve higher accuracy because basically we remove the error propagation problem. An error can be fixed. An error in the first component cannot be fixed in a pipeline approach, but it can be fixed if you're learning all these components together. There are some shortcomings of multitask learning on having everything done together. The model gets much more complex. It's hard to debug errors. It becomes more of a black box than before. But I think the trade-off is worth it. Um, the second, well, there's actually one example of this lesson learned, which is this paper that we've published called Knowledgenet. We create a data set for this problem of populating a knowledge graph, and was published in NLP in 2019. And the paper shows that basically this pipeline approach has huge error propagations on these steps. We use the Stanford system as our first baseline. We try to improve upon the Stanford system with better and better components, but we got to a point where we could not improve anymore because of error propagation. And you can see those at the bottom of the leaderboard. And later, after the paper, we start creating our joint model that does all the steps together, and also evaluating other systems that did this. And yeah, the multitask learning was getting much better results, and they're in the top of the leaderboard, much closer to the human performance than the bottom ones, which use pipelines. The second lesson that we learned is that small, high-quality data sets are better than large, noisy ones. Weak supervision has been a topic, a hot topic for some time in information extraction. The idea is that you can get training data for almost free, or automatically generate training data. There's a lot of people looking at this because especially deep learning approaches are quite data hungry. So many people looking at this problem and trying to figure out ways to generate training data. And we found that our time as a research engineering team was actually better spent creating tools for us to quickly create high quality data sets rather than spending your time trying to generate um, large amounts of noisy training data. Um, and some of the things that we've found very useful are, take all the unlabeled data that you have. Um, sure, make an effort to figure out which unlabeled data is more valuable than the other, but just don't use the automatic output directly into your models. Try to pass it through a human creation step. It's something close to active learning, but it's not. We're not using traditional active learning where the learner model is telling us which examples to annotate. We're actually creating tools to allow our annotators to find the problems that we might see in production. Right? So they can search for passages that have certain keywords or don't have certain keywords, but the system is telling us that there's a relationship. For example, we've found many examples where the system was telling that two people were married, but there was no keywords for marriage anywhere in the sentence. So we used that to basically filter the passages to annotate very good negative examples. We can use the threshold of the system to find these passages as well. Another thing that we tried, and we have now working well, is semantic search. So if you see the system not doing well one specific sentence, we can say, give me more sentences like this so that I can annotate. And this has been allowed us to improve very quickly the quality of models. And while not taking up the engineering and research time, right, we can actually work on other things while these tools are being used to improve the model by our data curation team. Engineering time is very valuable. Sometimes it is better to be spending somewhere else rather than automatically generating noisy data for training. The third lesson that we learned, personally, that I learned, is that entities of migration at scale is actually quite hard. I've seen all the customers doing this mistake as well, where they take they are not using any entities of migration system using machine learning. Right? So when they see a document like this where it says, there's plain text saying Diffbot was founded at Stanford University. It was the first company founded by StarX, Stanford's own campus venture capital fund. They tend to say, well, we actually don't need disambiguation. All of these names are quite unambiguous. We can just have some certain rule system that, if you see Stanford, it links to Stanford University. And it turns out that as you grow the number of entities in your knowledge graph on your database, even names that appears to be unambiguous, they start to be quite ambiguous. Like Stanford, we have over 7,000 organizations that have somewhere Stanford in their name, and 30 organizations that have StarX in their name. So the problem of looking at a name and link that name to an entity in the knowledge graph, it does require very sophisticated machine learning to be as you scale, basically. I know there are several of our customers come to us to help them improve this aspect of the system, again, because as soon as they go from a small collection of companies or people entities to a much bigger one, this is a problem for sure. Very well. So I want to talk about some takeaways about our conversation today. First of all, Diffbot is working to solve automated knowledge graph construction by applying NLP to the entire public web. We're crawling the web, trying to extract information on these pages. If it's plain text, if the information is in plain text, we're using natural language to go deeper, right? We've seen entity disambiguation, a named entity recognition, graph resolution, and relationship extraction as well. Our mission really is to help business leverage the web data for their competitive advantage. And this technology is actually fairly general purpose and can be used by virtually any industry. But I did mention some use cases for our customers in healthcare. They are interested in mining medical news, finding more what's being discussed on medical news, new technologies, what are the new players in specific industries on their healthcare, and they want to understand their competitors. They want to have a better understanding of the market, what the market trends, and they are also looking to find new sales opportunities. As I said, there's over 14 million organizations that are involved in healthcare in some way, and we help businesses find other businesses where they can have commercial relationships. This could be supply chain management as well, or lead generation, anything that creates new sales opportunity. Very well. I want to thank the organization of the NLP Summit for inviting me, and I want to leave my email here in the bottom so you can contact me about questions on this presentation anywhere. Any slide, please send me an email. If you think our technology can help you and help your business to achieve your goals, please send me an email as well. I'll be happy to give an in-depth, even more in-depth demo of our tools and see how they could apply to your business and to your problem. We do work with big Fortune 500 companies, mid-sized companies, startups, and even research institutions that can use our data for research. So if you're in this cohort of business and companies and you're looking for to solve a problem that we perhaps can help you with, please, again, send me an email. All right. Thank you.
What an excellent presentation to end this conference day. A huge thank you to all the speakers for their insightful talks covering state-of-the-art NLP in healthcare and life science. Many thanks to all of you for joining this community event yesterday and today, and for contributing with questions and with your own experience. Over the last 2 days, we have heard more than 30 sessions how NLP is leveraged to improve quality care for patients, the work of medical professionals, as well as how the technology can be applied to accelerate innovation in healthcare and life science. There are so many amazing applications of NLP in this field, and we are excited about everything that is yet to come. If you'd like to catch any of the sessions again or watch those that you have missed today, you can come back here and watch all the content on demand for the next 2 weeks. All the content will be available on this platform shortly and will remain public afterwards. For all of those who would like to dive deeper into applied NLP, we'll also be back next week with 4 days of virtual Spark NLP training and certification. The workshop will walk you through state-of-the-art NLP using Johnson Labs' open source Spark NLP library, as well as the Spark NLP for Healthcare library. Check out the link in the chat to see details and to register. Once again, many thanks to all of you for joining. We are very proud to be part of this amazing global NLP community. Keep in touch and have a wonderful rest of your day.